is for calculus AB, free response question 3, which is the non-calculator section. For question 3, you are given the graph of gx, and this gx is the derivative of the function fx. So for this case here, you have g of x, and this is actually the derivative for f of x. The function g is defined from -5 to 3 as piecewise linear, and from 3 to 6 as a quadratic function. You are given that f at 1 for part A, f at 1 equals 3, and we need to find the value of f at -5. Now for this case, you know that f of x is the antiderivative of g of x. So for 3 parts A here, what we could do is, since fx is the antiderivative of gx, we can integrate g of x with respect to x from -5 to 1. And that is given by f at 1 minus f at -5 from the fundamental theorem of calculus. Upon rearrangement, we see that f at -5, this is given by f at 1 minus the definite integral of g of x from -5 to 1. Since f at 1 is given by 3, we know that this has a value of 3. And for the second part here, the definite integral of g of x from -5 to 1, that is just the area in between the graph of g of x and the x-axis from -5 to 1. Basically, we are looking at this area here until 1 here. And since it is a definite integral, we are looking at the sine area, meaning that this part is actually the area of the triangle from 0 to 1, and you need to subtract the area of the trapezium from -5 to -1. Now the area of a triangle is half of base times height, which is 1 and 2 here, and you need to subtract the area of the trapezium. So you have half of the height, which is equals to 3, and then you need to add 4 to 3 here. So from here we see that f at -5, this is given by 3 minus, that part is a 1, minus, so from here 7, 3, you have 21 over 2. And this gives you the answer of 25 over 2. Now that is for 3 parts A. Let's move on to 3 parts B. For 3 parts B, we are to evaluate the definite integral of g from 1 through 6. So the definite integral from 1 through 6, we are looking at this part here, which is from 1 to 3, and you have the area of a square, and on top of that, from 3 until 6, that is the area between the graph of the quadratic and the x-axis. So for part B here, to find the definite integral of g of x from 1 to 6, you just integrate g of x from 1 to 3, and you add with the definite integral of g of x from 3 to 6. That gives you the area of a rectangle, and that area of a rectangle, you have 2 times 2 here. So that gives you a 4, and to integrate g of x is given by 2 times the square of x minus 4, and you integrate this from 3 to 6. So from here, this integral, the indefinite integral is given by 2/3 x minus 4 to the 3 from 3 to 6, and that gives you a 6 here for this part, and you have a value of 10. So that is for parts A and B. Now we will look at C and D. For part C here, for x in between -5 and 6, you are asked to find open intervals where the graph is both increasing and concave up. Now the graph of f, this graph given to you is the graph of g of x, which is the derivative of fx. So we are not looking at the graph of g to find for increasing and concave up. Now the first information given is that f is increasing. If f is increasing for part C here, you are given that f is increasing. F increasing, this indicates that its derivative must be greater than 0. Since the derivative of f is g, we are looking at the part of the graph where g of x is greater than 0. G of x greater than 0 indicates that the graph of g must be above the x-axis. So the interval that we are looking at is from 0 to 4 and from 4 to 6. So this is the first information that we have. So we are looking at the interval from 0 to 4 and from 4 to 6. The second part that is given to you is that f is concave up. If a function is concave up, its second derivative must be positive. The second derivative is positive, meaning that the derivative of g must be positive. The derivative of g is positive. This indicates that g must be increasing. Now g is increasing on the interval from 0 to 1 and from 4 to 6. So g is increasing from 0 to 1 and from 4 to 6. Then in that case, f is concave. F is increasing and concave up on the interval from 0 to 1 and from 4 to 6. So basically we are looking at this interval here. So 0 to 1 is on the interval from 0 to 4. 4 to 6 does overlap. So f is increasing from 0 to 4 and 4 to 6. And f is concave up from 0 to 1 and from 4 to 6. So that overlap, the intersection of the two intervals is actually the interval from 0 to 1 and from 4 to 6. That is for part C. For part D, you need to find the x-coordinate of the point of inflection of the graph of f. So when we talk about a point of inflection, a point of inflection is the point where the second derivative of f is 0. So when we talk about the second derivative of f is 0, that means the derivative of g is 0. The derivative of g is 0. This occurs only when the graph of g changes from increasing to decreasing or from decreasing to increasing. We are looking at this point here. The graph of g decreases and then increases. So that is the only point where the graph of g changes from decreasing to increasing. There is no other part where the graph of g changes from increasing to decreasing. Therefore, the only point of inflection is at x equals 4.